So far, we've considered validity as it applies to the variables, but the overall idea also applies to the study as a whole. In other words, we can also ask if the entire study is actually testing what it claims to be testing. When we're thinking about it in that way, we're essentially asking what claims are actually supported by the results of the study. When we're thinking about the validity of a study, we can separate it into internal validity and external validity. Internal validity is focused on how the parts of the design work together. External validity questions whether the method and design support conclusions about other people and situations. There are often trade-offs between internal and external validity. Maximizing one may reduce the other. So understanding the related concepts is important for deciding what to prioritize and how to apply the resulting findings. It might have already occurred to you that representativeness is one of the considerations when we're considering external validity. If the participants aren't representative of the population and the research process isn't realistic, we would say the study is low in mundane realism. This relates to one of the questions for scientific literacy we've been working with. Will the results survive the trip from the laboratory to the real world? If a study is low in mundane realism, we probably wouldn't see the same thing in real life that the researchers saw when they conducted the study. We can also question whether the mental processes participants engaged in during the study are the same as the ones that would take place in a similar situation in the real world. If so, we would say the study is high in psychological realism. External validity requires both mundane and psychological realism. If a participant is using the same mental processes but in an artificial situation, it creates questions about what would happen in other situations. Internal validity is concerned with whether a part of the design reduces the degree to which we can be confident that a change in the dependent variable was caused by a change in the independent variable. The terms independent variable and dependent variable in the definition obviously mean it's limited to experimental studies. Indeed, non-experimental studies, such as correlations, are much lower in internal validity because the designs don't support conclusions about cause and effect. We can still use the ideas to consider the strength of non-experimental studies, though. In some cases, they influence our confidence about the relationship between variables, whether it's cause and effect or not. Notice that the graphic in this slide depicts the non-experimental design, the correlational design, as having the potential to vary in its level of internal validity. It doesn't say, nope, no internal validity. When a part of the design reduces our confidence in whether the study accurately tested the relationship between variables, we say that part of the design represents a threat to internal validity. There are 9 threats that tend to represent most of the reasons that we question cause and effect. This slide includes 8, and the 9th is the interaction between 2 on this list. The tutorial from Athabasca University provides a really thorough explanation and practice in determining the threat with examples, so make sure to use that resource. I want to emphasize 2 things that aren't directly included in the tutorial. The first thing I want to emphasize is that some of the threats are not applicable to all research designs, regardless of whether they are experimental or not. Of the 9 threats that are commonly identified, 3 apply to all types of studies. It might have already occurred to you that selection threat would overlap with representativeness for non-experimental and quasi-experimental studies. There's also the potential for a researcher to influence responses regardless of the type of study. In this slide, I changed experimenter to researcher to provide that cue. Notice, too, that I put bias in quotation marks. I think sometimes we think of bias as resulting in more deliberate or overt behavior, but in psychological research, the influence can be subtle, like the way the instructions are written, or even the questions on a measure influencing what the participant thinks the researchers are looking for. Any study using psychological or observational measures can also be influenced by instrumentation threats. 2 more threats are applicable when a study uses a process that involves measuring the same variable more than once. That might be done to determine changes over time or to determine the effect of an intervention or event. When the same variable is measured before and after an intervention, it's sometimes called a pre-test post-test design. In those cases, something about the first measure influences the responses later. For example, the participant could remember how they responded to self-report measures and become more comfortable with the device for the physiological measures. Overall, the idea is that the second and any later measurements may not be accurately measuring the variable. Regression to the mean is a phenomenon that's been identified in many settings, not just research. The idea is that extreme results, positive or negative, don't continue. In most cases, the results of the measurement tend to get more typical. The last three threats are only applicable if a study is long, either in actual longitudinal study or another design that requires gathering data over time. Experimental mortality is a complicated way of saying participants might drop out. Depending on how many participants drop out and whether there are any patterns in who drops out, it can influence the results. The overall idea of history and maturation threats is fairly straightforward. Participants experience other things other than the study. The difference between the two is that history is concerned with outside events, like major world events, cultural changes, and natural disasters. Maturation is changes within the person. And the ninth threat is a combination of maturation and selection, which might help maturation make more sense. Maturation alone is things like changes in thinking due to cognitive development. So if all participants in one group are also the same age, selection and maturation can combine so that the group changes, but because of something other than the study. I mentioned there were two things I wanted to emphasize, and one was that not all of the threats are applicable to all studies. The second thing I want to emphasize is related to that. It's not inevitable that a study will have a threat to internal validity. When researchers take steps to avoid threats to internal validity, it's sometimes referred to as controlling for threats to validity. In the case of the threats that are unique to particular designs, researchers can use procedures to control for the threats or use a different design. For example, random selection and random assignment control for selection threats. Written instructions and double-blind studies control for researcher bias, and reliability checks help avoid instrumentation threats. Threats due to repeated testing can be controlled for by using research designs that help reduce the impact in the overall analysis, or provide a way for the researchers to test for the influence of repeated testing. For example, if the score changes for a comparison or control group that didn't have an intervention, then the researcher might conclude there was a testing effect. Changing the order different groups experience different parts of the study can sometimes average out the influence of repeated testing, so to speak. Regression to the mean is controlled for in the analysis process. The three threats that come into consideration with longer studies can sometimes be controlled for through design, like a cross-sequential design instead of longitudinal. In some cases, the research in question and hypotheses can't be addressed without collecting data over time, in which case we watch for an indication of threats to validity in the number of participants who finished compared to the number who started, and events that might create history errors. Considering participant characteristics allows the researcher to watch for potential maturation threats. Both internal and external validity relate back to the larger question of whether a study is accurate, whether the design, method, and process of carrying out data collection supports the claims the research is making based on the results. Internal validity is focused on how the parts of the study work together, while external validity is concerned with whether those components are similar to the real world. While there are ways to minimize the threats to both types of validity, they might also reduce validity from other perspectives. Given that, researchers have to consider the trade-offs when making decisions. As consumers of research, we need to keep in mind that internal and external validity are important considerations in evaluating the credibility of a study. In some cases, they don't completely take away from credibility, but they do influence the practical meaning of a study and suggest alternative explanations, as well as potential questions for follow-up studies. Occasionally, though, considering external and internal criteria can lead to the conclusion that a study isn't credible.